Hi everyone, I'm Yiğit, one of the general partners at Vela. And what we do is that Vela is an AI-enabled venture capital firm investing in early-stage startups. And how we do it is that we collect data using crawlers and APIs and interpret those data sets with statistical models and machine learning to find promising startup investments. And one of the empirical evidence after talking with thousands of startups is that the ones with clear business models have a higher likelihood to succeed. So to identify that, I work with Zülal, Özlem, Ardahan, and Oğuzhan to develop a new model to predict pricing and business models of startups using data and machine learning at scale. So I'm grateful, and the team is very grateful of the work and excited to incorporate the team's findings into our larger algorithmic model. Thank you very much for the amazing work so far.
In the literature, main approaches for data enrichment implementation are generally depending on usage of machine learning, web crawler, and having valid testing through training data sets. Natural language processing is used to read and understand human languages with the principle of artificial intelligence. In order to gather textual content of the website, one approach is using a web crawler for accumulating the desired data by searching an enormous number of web pages in a short period of time. For our project, machine learning is used to predict pricing page presence. We predicted startup's pricing model by determining whether it has pricing information or not on its website. In our past study, we had approximately 1,000 startup data and we had 3 attributes: funding amount, founding year, and pricing information on the website. We applied benchmark model including different prediction models such as linear SVC and random forest classifier. In the final step, we enlarged our data. It contains 3,005 startups with their experience year, funding amount, pricing information, rank, country, sector, and description. Also, we reached their websites by using web crawler and obtained textual content. We used Python software, Jupyter Notebook, and machine learning to develop our models. We tried benchmark approach with several prediction models. The ones with highest accuracy rates were Random Forest, Bernoulli NB, Pipeline, and Linear SVC. Their ROC AUC rate is approximately 0.8. However, we got the best score with XGBoost model. We vectorized the attributes so that they can be perceived and interpreted with machine learning. In order to get the best predictor score, XGBoost was required to repeat with the given parameters. Firstly, 1 and 0 ratios were stratified for train and test data sets. Since test data was 20% of the entire data, we used stratified 5-fold cross-validation. Then, we used grid search cross-validation to get optimal parameters. XGBoost model requires parameter hypertuning to improve and become advantageous over other algorithms. Therefore, we tuned our fixed parameters. We ran parameters for each fold and we got mean values for each result. The overall mean is 0.83. ROC analysis provides tools to select possibly optimal models and to discard suboptimal ones independently the cost context or the class distribution. Note that there is a trade-off between hit and false alarm rate. In our model, catching true ones are the main point. However, increasing hit rate also increases false alarm rate. We analyzed the keywords that generate positive and negative signals by using linear SVC. As you can see, online and product keywords generate positive signals. Therefore, we can say that startups that provide online shopping have higher likelihood of including pricing information. On the other hand, technology and data keywords generate negative signals. Hence, we can say that startups based on artificial intelligence and technological services have higher likelihood of not including pricing information. Furthermore, we combined description and textual content of the firms. As you can see, keywords detected from textual content have higher weight such as pricing, shop, and free. Lastly, we analyzed the sectors. You can see the most significant sectors for our data. In the parenthesis, left number implies number of firms that do not include pricing information and right number implies the ones include. We have developed the first step of predicting business models by constructing an algorithm that can predict pricing models of the startups. It can be a valuable model for Vela partners for the decision-making of investments. Also, our model can be easily integrated with further studies. It is compatible with various algorithms. It was a great experience for us to work on this project. Thanks for watching.